All right, hello everyone. Welcome back to my journal. So today we going to solve another problem. Same graph problem. Sorting past to get food. As you see, when you see sorters, you directly know that it's gonna be BFS. It's gonna be a BFS approach. But anyway, just I'm gonna walk you through the problem. So we have So if you are starving, you want to eat food as quick as possible, you want to find sorted paths to arrive to at any food cell. Okay. So you are giving the n by n matrix spread. Star is your location. Okay. And there's only one star, that is just hashtag is the food cell, and there's many multiple food cell. Always a free space. You can travel on this cell, and X is obstacle, meaning that you cannot travel to the this cell that have an X. Okay. And you can travel any adjacent cell, north, east, south, west. This is just like go up, down, left, right. Return length of a source path to reach any food cell. So any, meaning that it is a specific food, just any of them. If there are no path, you can return -1. Okay. So let's say you start from here, right? But you have to go up, left, right, or down only. So BFS function, what it does is, okay, it's gonna have a queue right here. Simply, your starting point is gonna be right here. Let's say 0, 0, 0, 1. So which one is 1, 1? All right, this is your start cell. So the BFS will start scanning this for right here. So now let me just add a color. Uh, we'll add this into um our queue. We published one already. Solution gonna be out. So when we publish one, we process the top, left, right, and bottom like that. So we add them into the queue. So right now in my queue, I have 0, 1. I have 1, 0, 1, 0. I have 2, 1. Yep, like that. And I also have uh, something like that. Sorry, a little bit messy right here. Okay. And that is where we process. And on each of these points right here, right, each of that point, we will continue processing. So for take this as an example. So here we process it, but it's outbound. So since this one is outbound, we gotta not processing it. So we just pick it off. We process this, we process this, we go back to process this, but this one we already visit. So we might need a visit asset for this one. So since the one we already visit, we have to um fix that we actually move them. So we can only process this, then we can move this boy. We go on to the next one, 1 and 0. Right, 1 and 0 is right here. We process this. This one is southbound. This one is visit. So only this one. And also remember to destock into the queue. The player at which one it's the 0, 0. Which one is 0, 2. So we add these ones to the queue. Same thing. Same thing with this one. We process this. We process this. We don't this one. We add them to the queue. Go on. For this one. Oh, yeah. we're going to process this, and then that's it. So, so right now we are at two steps. If you see the two color with another pink color right here, you can only process, let's say, from this side and push up. That's right, and this one all found the powder and food like this. So when we found the food, we return it right away. So that'll be three, yeah, three steps. So this one layer by layer, and BFS algorithm will guarantee 100% sleep after short to the food. Uh, and that should be it. So let's start putting some now. See? So first of all, as I always like to approach, I will have the row, the pro, the column for my grid length, uh, grid, with also and grid two right here. Uh, I also need the Q right here, row column and zero. Also have a visit, which is set, right? And then we need to uh, loop through, first of all, we need to loop through the whole grid to get the starting point. Uh, So, um, the column, something like that. And then if the grids, row, column, we go to star, which means it's a start point, we will append the two would groups. I'll also put this into the visit. This is our starting point. Oh. And then I break since we don't need anything from this loop anymore. And then right now I just note this one is gonna be and to go through over grid. And then I will the direction. And well, for that I always have this kind of direction. One, one text was the ones go and then zero this one. Like that. That four. Then y two or you bring this is just standard traversal. So you have roll for this one. Let me just some cut this is. Let's just do X two and here I will put draw the columns and so we keep track of the step. It's all column and step. We pop less. So they're just out my head. Um, Unfortunately, I want to remember that if the grid, let's say, is smooth, right? Thinking going powerful with kind of stuff. Uh, and then everything underneath is not good. So we have to check the neighbor as we go. So for direction, on the direction row, then direct them without new row and we have new time, which is a row plus the direction, the column plus the direction column. And if this when I say outbound, so either of this, right, so row the column is 0.0, I will not add it into my queue to process something with the neo row or the column. This means text outbound on the other side. Mm, And also, if the grid is the obstacle, here, oh, obstacle in the what? Obstacle is an X, email. Um, we the we already visited. Well, visit and we continue. And then I also this one is totally optional. We can do it or not do it. It's still gonna work. Is if the grid, if I found the food directly, I would just return right here. One. I would just return the food right away. You can either put it in the queue and wait for this to happen, or you can just return it right away. But right here, just return it right away. Optional. Just a small little optimization. Right here, if I add everything into my business, uh, and oops, roll up, roll, roll in it. That all set to the queue, the manual and call, step to move on to the next step. Yeah, and then after that, we, in case we are not returning anything on the step right here with a -1. All right. Yep. So for this problem, since we are using BFS to traverse and we look through the first one, we look through the grid. So I step all and also we traverse the grid using BFS. So that one is also cause opacity. So it's also all of boom. And for the straight, we use visit and the queue to process every single node. There's gonna be also all n times n. Yep. And that should be it. And let's start running it, see if it's work. Yep. And that should work. If we looking at our content, please like, subscribe, and I'm going to see you on the next video.